Hello, my name is Chris Deutsch. I work in RightScale Operations. I've been working at RightScale about 2.5 years now. And in this talk, we're going to be talking about two things: monitoring and automation. We're going to try and divide it about 50-50. We're going to talk about how monitoring works at RightScale, how to build your own custom monitoring and hook it into RightScale, how RightScale Operations uses the RightScale monitoring system to monitor web applications and Cassandra using these custom plugins, and also how RightScale Operations actually automates live releases in the cloud using the RightScale API, and a command line tool we use to do that, which we're actually open sourcing today, which is pretty cool. And if we have time, some just miscellaneous tips from ops and Q&A. I think we'll have some time for Q&A. So let's get started. So RightScale Operations is a team of 7 people. We're running over 700 servers in the cloud. We run 24/7 across 5 continents. We have ops team on 2 different continents, so we can run in different time zones. Someone asked me earlier, why do we run so many instances and why are we in so many continents? The answer is that where our customers run, we run. So if you want to be able to run servers in both Amazon US East, Amazon US West, and you want to deploy some servers to Australia or something, we're going to run in all those places so you can get all the resources you need. And RightScale Operations is the group within RightScale which is in charge of all that. Now, because we're RightScale, we're really big believers in using our own stuff. So we actually run RightScale on RightScale, which is kind of crazy and sounds maybe hard to understand. But basically, there's another copy of RightScale that runs RightScale, and we work on that. So every single thing we do to improve all the automation, all the monitoring on RightScale, usability, everything we work on feeds right back into the product. Okay, so why monitoring? Well, monitoring is really, really important with regular physical servers, right? You need to know if something is overheating, if it's going to catch on fire. You need to know if your disks are going to be full, if they're dying. It's even more important in the cloud. I don't want to say, it would sound really bad if I said something like the cloud is less stable than physical servers, although maybe some of you would agree with me. So instead of saying it like that, what I'm going to say is in the cloud, you have to plan for HA and DR, right? So monitoring is really, really important because you have to know when your systems are working and when they're not. So I think it's actually more important to be able to monitor and automate in the cloud basically because of these things. It basically, maybe you could kind of limp along without really good monitoring before, but now that you're in the cloud, you have to have the good monitoring and the good automation if you really want to be taking advantage of everything. So RightScale, really big into open source. All of our monitoring is basically based on the open source chimpd system. Anyone here familiar with chimpd? Yeah? A few people? Cool. Okay. What's cool about chimpd is it's modular. There are lots of freely available modules for different types of database servers and host metrics available. Our monitoring system uses RRD files to store data, if people are familiar with RRD. The way the API works will be really familiar to you. And highly recommend you check out chimpd.org if you want some more information on that. So now that we know how it works behind the scenes, let's take a quick look at the actual site. So here I am. I'm going to open this server up called monitoring demo. Oops. Now, how many people here are currently running production servers on RightScale? Awesome. Okay. So this is probably already familiar to a few of you. How many people have not played with the RightScale monitoring before? A few too? Okay. Cool. So basically, when you launch a server, RightScale automatically configures it to report to our system and registers all the monitoring for you. So you don't have to do anything. And when you click on the monitoring tab of a launch server, you get all this cool stuff. So you have, your default CPU monitoring graphs, and you can go back, a week. This server hasn't been running for weeks, so I don't have any data going back that far. You can look at your disk, you can look at your memory. These are just all the kind of basic host-level metrics that you'd expect. Now, you can take these metrics, and over on the Alert tab, you can use them to define alerts. Like, for example, we have one on here where if the idle value of the CPU is less than 15 for 3 minutes, then escalate to warning. So through these alerts, you can use the metrics to do all sorts of stuff. You can say, hey, page me, wake me up. This also feeds into auto-scaling, so that's important too. So I don't want to get too deep into how the alerts work. I just wanted everyone to kind of see that they're there in case you haven't had too much experience with them before. Is that pretty clear? This is just kind of introductory, yeah? Okay. Cool. So let's take a look then. Let's start getting into the fun stuff. Let's see how this all works under the hood, and also see if Google can handle going back and forth between my presentation. Okay. So these are some of the built-in plugins we just saw. I'll skip that. So how does it work? Okay, so when you launch an instance on RightScale and you're using one of our server templates, you're automatically going to get collectd running on the instance. It's going to run right there. And what collectd does is it pushes data. It pushes it over the network to a server at RightScale, which we call a sketchy server because they draw a lot of graphs. And there's a local data store, and it's stored in RRD, so it's rolling up all the data for people who are familiar with that. And let's see here. Yes. So when you come in through the dashboard to look at the metrics, it's the same thing just going in the other direction. You grab the metrics from the sketchy server, it comes in through the RightScale dashboard to the web client, and it's actually the same thing if you're an API client. It's just going to go back there no matter how you access it. So let's see. Where are we? Ah, yes, custom plugins. Okay, so now the presentation really starts. Now we're going to get into the fun stuff since we laid a little bit of groundwork here. So why do we want to do custom plugins? Well, I already said that monitoring is super important in the cloud. Well, it's one thing to set up an alert to say that your system is running low on disk space. But what you really want is you want tests that say things like, is my software product working? If I've got some kind of message bus, send a message into it, pick it up on the other end, right? What's the latency? How's that working? Send me a warning if things slow down, all that kind of good stuff. And you can actually do this with the RightScale platform. I got caught. Okay. So where was I? Oh, yeah. Okay. So in collectd, use the collectd plugin, or sorry, the exec plugin to do this. So how I already said collectd was very modular and has all sorts of different modules? One of these modules is actually called the exec plugin, and it just runs a program. And that program, which I'm going to show you an example of in a second, is super simple to design. It has a very simple API. You can write it in any language. We're going to look at it in Ruby because RightScale loves Ruby. Yeah, cool. Okay, so let's take a look. Let's see here. Oops. So here I've got my monitoring demo server. This is the one that I just showed you, actually. And if I look on here in monitoring, you will see that there is one monitor here called example. And all it's doing is outputting a 1, right? So you could think of this as kind of a Boolean value, as in 1, my example's working, 0, it's not. Luckily, it's working. So let's see here. I'm going to go ahead and SSH into this instance. Cool. All right, and I've installed this plugin in user local bin. And here's what it looks like. So how many people here are familiar with Ruby? Is there anyone who's totally baffled by this? No? Oh, great. Okay. So very simple. If you can make out what's going on here, basically we're saying loop forever, and every 20 seconds output on standard out this line that says put val, beginning with the host name, and then example, gauge example, the time in seconds and 1, the standard Unix time thing. So you can actually just run these programs to test them. And this is, oh, that's funny. So if my host name was name, that's what it would look like, right? It's just going to print out, put val, name example, gauge example, with the time in seconds in a 1. And it's just going to do that every 20 seconds. And the exec plugin will basically listen to this guy on standard out and report all that stuff back to RightScale. So that's really simple. It's about as simple as you can get, really. Now, how do you actually tell it to run this plugin? Well, there's two parts to it. The first part is you got to tell collectd to run it. So in a config file, and you could call it whatever you want in that collectd directory, you just tell it plugin exec needs to run as a user. We run it as nobody. Example.rb. That's the name of the script. That's all you have to do. And then, there's your script. You're basically done. So very, very simple, very straightforward, very powerful. So let's take this idea, let's take this really simple script and do something much more exciting with it. One of the things that we've found is really useful at RightScale is to monitor HTTP response codes in general. Why might you do this? Well, RightScale has a RESTful API, right? So when you make API calls, the API is going to be returning response codes. It might be returning 400s if something isn't available. It'll be returning 200s if it is. If it's having internal errors, it'll be returning 500s. So by monitoring these, you can actually get a really good idea of how a system is performing. For example, what if everything seemed to be working correctly, but there was a huge spike of 404 errors from an API server all of a sudden? That's the kind of thing that would warrant, taking a look at. Now, this is actually really cool. There's a common pattern we found in monitoring that works really well, and it's very, very low tech. It's basically automatically tailing the log file. There's actually a Ruby module called file tail that you can use to do this, and I think there's some for other languages too. And so all you have to do is say, hey, my web server's logging here. I'm going to watch everything that comes out of that log file. I'm going to collect the metrics on it and report it back to collectd. And so this diagram is basically just showing that, we're going to use an Nginx web server. It's going to output to a log file, and then collectd is going to run our plugin, which is going to read from the log file. So what does this look like? I keep wanting to Alt-Tab out of here. Ooh. I think that... So this is one. Perfect. So I'm using some, these are actual servers. They're not production servers, but they're from our test environment. So they have actual data in them, which is pretty cool. So you see here this plugin HTTP error rates. Now, admittedly, this is going to be very boring because everything is hopefully working correctly. Oh, okay, so this guy's been having some problems, it looks like, actually. That's cool. Thanks for a better demo. So you can see here, actually, let's look at a good one. Let's say 91.1, that's the one I wanted to look at. Ah, here we go. Okay. Right. So in this case, what we did is we have a separate graph for each type of HTTP response code. Now, when I'm looking at things from a bird's eye view, I really don't care if somebody got a 200, a 201, or 202. I just care that they're 200s, 300s, 400s, 500s. So you can see here, this graph is just a graph of the percentage of HTTP 200s being returned by this server. And then we also have graphs for 300s, 400s, 500s, et cetera. So let's take a look at how this actually works. Now, it's more sophisticated because it has more graphs, but the API is still the same. It's just using all those put val statements. Whoops, IDRSA. Okay, so first let's look at our collectd configuration. That's going to be in set collectd. There's a main configuration file called collectd.conf right here, you can see. It's basically just loading these plugins. Let's see, it's cut off a little bit. Let's do that. Okay. It's basically loading these plugins. And so one of these plugins is exec, which, as I mentioned before, is the plugin we're using to do this kind of monitoring with. And then in this conf directory, here is the http arrate.conf. And you can see here what we're doing. We're running it as www data, because this is a web server. That's our web server user. It's being run under Ruby, because it's a Ruby program. Here's the name of the script. Here's the hostname argument. And the -i20 means report back every 20 seconds. So the hostname argument here is very, very important. I kind of glossed over it with the first plugin, but that ID may look familiar to you. It's actually what's called the sketchy ID. And that's how RightScale knows where to send the data. And if you look on the dashboard, you can see that right here where it says sketchy host ID, like that. And the way that you set that is with an input. Basically, when you install your plugins, and I will show you here how this one works. Let's see. Our HTTP monitor. Uh-oh. Here we go. You see how it says server UUID equals env rs instance UUID right here? Whoops. See if I make that a little bigger. Yeah, right there. That's the value you want. So that's getting substituted by our little script here and put right in here, and that's how RightScale knows where to go. Now, just like we did before, we can run this at the command line to test it. And this is pretty much the best way to debug these things. So you can see here, already it's running. And what it did is it just went, and it's using that Ruby file tail module, it just went and said, hey, it's kind of like a sliding average, like a load average under Unix or something like that. It just said, hey, give me the last X entries. What are their error codes? Let's start figuring out the percentages, et cetera, et cetera. And so when we're working on new plugins like this, usually what we do is we just run them direct from the command line and run them like this, make sure everything's working right, and then we eventually hook it up in the monitoring system. But this is a great way to just kind of develop them while you're interactively, I guess would be the word I'm looking for. Okay, so yeah. Let's take a look now at a different kind of monitoring example too. So the third and final monitoring example I'm going to give you guys is a Cassandra demo. Now, how many people here have heard of Cassandra before? So, quite a few. How many people here know what or have heard of NoSQL database servers? Pretty much everybody? Okay, so Cassandra is a NoSQL database server. That's pretty much all you need to know for what we're talking about. So don't worry if you haven't heard about it. It's very cool, though. You should check it out. And it's distributed. It stores the data on different nodes. So the monitoring of this is very important. One thing we found, for example, is that bad performance on one node in a Cassandra ring can drastically affect the performance of a ring as a whole. So we need to monitor each individual node of the ring extensively and find out exactly what's going on. So the way that this works, since Cassandra is written in Java, we use Java JMX, which is Java Management Extensions. and a plugin called MX4J, which basically allows you to do XML over HTTP to get at all that Java JMX info. And Cassandra exposes all of the interesting metrics through JMX. So I have here, whoops. Let's bring up the Cassandra server. By the way, if any of you here are interested in running Cassandra on the cloud and like the kind of monitoring we have, you should bug your sales and service people to make them get us release this template to the public, because I think it'd be really cool. Oh, wrong place. Okay. So, as you've noticed, the examples are getting progressively more complex. And now we're at a place where we've got just tons and tons of monitoring information. So you can see here, I have a Cassandra key space. It's called audit entry details. And here, I'm looking at things like what's the max row size, how much disk is being used, how many requests per second, what's the latency for this, that, all sorts of stuff. So you can get pretty, pretty darn complex with these things. You can see stuff like that. And this is, again, this is the same, just the same thing. It's just running collectee on an instance, gathering the data, sending it back to RightScale. We roll it all up for you, make the nice graphs. Super easy. So let's check time here. Before I go on to talk about automation, does anybody have any questions about monitoring or anything we've gone over so far? No? Yes? Oh, yeah, get a mic on this guy.
It's not a question. It's just like we're using Cassandra very recently, so we got a couple of clusters for Cassandra. So you think the solution is readily available that we can use right away? I can bug the salesman for sure, but I will only bug. I
can't. You know what? I can't make those kind of guarantees.
Okay. I'm it's, even if it's like 60-70%, kind of satisfy requirement. So we can talk further and can.
Yeah. You know what? Talk to me afterwards, and I can tell you a little bit more about what we've got and see if it might help you out.
Trust me, you're gonna make my database manager very happy.
I mean, like I started out by saying we run RightScale and RightScale. Everything we do benefits the customers. So I really like to get this stuff back out to the customers. It just we need people fighting from both sides to do that. So, yeah, cool. Okay, so let's talk about automation. So, oh, another question. Cool.
Two quick questions about the HTTP example. First, what does that script do to the utilization of the load balancing instance? I mean, is it appreciable, or scraping that log?
Oh, like how much load does it put on the machine?
Yeah.
Not very much at all.
Okay, and then in a production environment, how do you handle log rotation and stuff like that? Like filling up the disk with that log, and if you just want to run that instance for a year or whatever and not touch it.
Yeah. I mean, log rotation is very important. I don't want to get too deep into it. I will admit I am known as the log rotate master in the sysadmin team. But yeah, usually what we do is we actually have centralized syslog servers.
Okay.
So that allows us to use a lot more disk and a lot better rotation policy. But on the actual instance that's running, we might rotate every day or every hour or something, and just keep a small amount of data on it.
Okay, and I assume the same thing would work in HA proxy?
I
mean, okay.
Yeah.
Okay.
Yeah, so it's kind of a cool pattern. It's like you can have a log server that stores long-term logs for archival and examination, then you just keep a few days of logs on your actual instance. Okay, looks like we got one more question.
Yeah, mine actually isn't a question for you. It's an answer for the fellow over here. Having written a couple of collectee modules myself, or exec modules, if you detect that your log has rotated out from under you and you just exit that module, collectee will refire it up and it'll reattach to the next log if you're coded it to do that.
Okay, let's make this the last question.
Yeah, just briefly, how does this configuration get to the client? Because it looks like you need the scripts there, you need the configuration there.
Yeah, that's a really good point. So the question was, how does this configuration get to the client? Now, what you need to do is have a recipe or write script that basically does the installation. So I will show you real quickly here my server template for this service. And down at the bottom here, you can see I have a bunch of scripts prefixed with mon, like mon collectd Cassandra, mon collectd Cassandra node health, mx4j. These are all different monitoring plugins that get installed. And they'll take that one value as an input, that server UUID, and we'll configure it. And essentially what it all just comes down to is, attach your plugin, install it, make it executable, and then write out that little exec config file that I showed earlier, and you're off to the races. Cool. We'll have some time for questions at the end too. So let's move forward here. Okay, cool. Skipping slides. Okay. So let's talk about the API. Right. So RightScale API is RESTful, so it's really easy to go in there and kind of play around and figure out how everything works. Operations uses it really extensively. We make literally thousands of API calls a day. No. We use it for making our production deployments. We use it during releases. We use it to automate our staging systems for our developers. We use it pretty much for everything. Now, before we get super deep into it, I do want to mention that there is a Ruby client library called WriteAPI Client that you should check out if you're into Ruby, because that'll make it a little bit easier for you. And there's another presentation Ryan Geyer from RightScale is giving on Cloudflows, which is our cloud orchestration framework, which you should also definitely check out if you're into automation like I am. And that said, let's talk about automating via the command line. So one of the things about being a systems administrator is it's probably one of the only jobs where you get rewarded for being lazy. And I am extremely lazy. I really hate doing the same thing over and over again. I hate manually typing commands. I'm sure all of you do too. So I designed this program called Chimp, and it's basically just a command line program that wraps around the RightScale API. And all it does is run stuff. So it's not going to build your deployments or build your servers. It's just going to run stuff for you. And I think the best way to kind of show this is to jump into a demo. So let me show you what we got here. So on this server, I've installed Chimp. And actually, let me show you how to install it first. So it's written in Ruby, and it's a gem. So you can just do a sudo gem install write chimp like that, and that will go ahead and install it. And once you've got it installed, it's going to make this chimp command line available to you. So the way that chimp works is it all works with tags. Now, if you look, let's see here, let's go here. If you look at your servers, drill down, this is what I'm talking about. These are the tags down here. Now, some of these tags are set automatically by RightScale, so you've probably seen them before, like RS logging state equals active and such. You can actually add any tag you want here. And you can also have instances tag themselves, which, pro tip, very, very useful. Add a boot script that tags your instance with its IP address, the software it's running, all that good stuff. It's going to make these chimp queries a lot easier. So what do I mean? Chimp -- tag, and this was chimp test equals true. So it's going to run out, contact the API, and tell us there are 3 servers that match that. Simple, right? Let's say we want to run a script on it. Now, these test servers I'm running have 3, or I think 2 different operational scripts. Temp test success and test fail. So I'm just going to say run this script named success. And it'll do partial name matching for me. So it's going to go to the API, it's going to query the server template, it's going to look everything up by name, it's going to come back, tell me the servers that it's going to operate on, because you do not want to make a mistake with that. Let me press enter, and then it's going to go ahead and just run it sequentially, 1 on each server in the simplest case. Now, because it's using the API, you can actually see it running in the sidebar here, too. Maybe it's already finished. Yeah, there you go. And it's going to generate audit entries and everything, right? So you can come in here and you can look and you can log, everything is logged. You can see what happened on your server. You can see if it works, et cetera. And it's going to detect when it finishes. Now, it takes about 30 seconds for this process to run and for the whole loop to come back and for it to see. So you can see here it took 32 seconds to run the first one. Now it's going to run the second one. So you could use this in all types of different scenarios. One of the most common that we have is we have a lot of servers running. You know, we got API servers running. We got different kinds of application servers running. And one thing you can't do is say, hey, take down all my application servers and update the code and restart them at the same time, right? Because that's just going to take your whole site down. So what we do most of the time are rolling upgrades. And this is what we use the chimp for. So you could use this to do a rolling upgrade where you say, hey, go to this server, do a code checkout, do a restart, make sure it works. OK, it's done. Now go to server 2. Same thing, server 3, 4, et cetera, one at a time. But in a lot of situations, that's just not enough. If you're doing everything one at a time and you've got 100 servers, that can take a really long time. So we ended up adding some pretty cool options in here for controlling concurrency and stuff. So I'm just going to cancel out of this. Now, I can keep the basic command line the same, and then if I just add a concurrency flag, it's going to do the same thing, but it's going to run them all concurrently at the same time, which I know I just said we never do, but so there you go. You can see it's running everything in parallel. I'm just going to quit out of that, too, because we don't need to wait to see if it runs. So the concurrency is arbitrary. One thing that you might do is you might say, I've got 20 application servers, update 3 at a time, update 5 at a time, something like that. You can also wait after each one is done, which I think is the delay option. So you can say, do it with a concurrency of 3, and also wait 1 second or wait 10 seconds between them. You can say, oh, do a dry run. This is really cool. You can say, do a dry run. Go through, tell me all the servers that you would select, find the script, do pretty much everything you would do except actually execute the actions. So we use this when we're doing our testing development. We can run a release in dry run mode, make sure all the API objects are there, make sure everything is going to work, make sure everything is good before we even touch anything. Pretty cool, I think. So let's jump back into the presentation. See what the next slide is. Right. So one of the cool things about this, too, is that you're not limited like you are through the UI into just updating things in one deployment, right, or one small set of servers. Because you're operating on tags, you can operate on everything, right? You can say, update all my API servers. Or if you had a tag that says, you know, these servers are running Cassandra version 1.1 and these are running 1.2, run an upgrade on the 1.1 servers and upgrade them to 1.2. Do stuff like that. And you can also track success and failure, which is extremely important. One really big problem that you will have in the cloud when you're updating your hundreds of servers is that one of them will not update correctly. Almost guarantee something will happen somewhere. And something will not work. So it's really important to track the success and failure of everything. And then what we usually do is say, OK, well, we tried to update 100 and 3 of them failed. OK, hit retry and just go back and redo them again. So that's all built in. OK, so the chimp is a very low-level command line tool, great for ad hoc type of stuff. I want to select some servers on and run some write scripts. But the really cool thing about working with the Unix command line is that that old Unix style of every little utility being really good at one thing, the chimp is like that, and so we use it like that. We put it in shell scripts. We use it in Ruby rake files. We do stuff like that. Are people here familiar with Ruby rake files? Yes? Do people here familiar with like C make files? More? Yeah. Rake file is a Ruby make file because everybody has to have their own stuff, I guess. Yeah, and that's what we use to tie it all together. So what I'm going to do is actually show you the release automation that we use using the chimp to fully automate our releases at RightScale. And because the chimp is open source now, it's actually something that you guys could check out as well on your own. So basically, if you look at the release automation, what we've got here is just a top-level script called tip.rb. And, whoops, you know, it has some options in here. This is all very much internal RightScale stuff that's not worth worrying about because this is really, really custom for what we're doing. But if you go into the lib directory and you look at one of these files, now let's see if I can. Yeah, okay. So basically, the format of a rake file is you define tasks, right? And you say task connect do, and you're passing in the task name as a parameter. And then down here, we have a little function we define in the rake file called chimp that runs chimp, and we just pass in stuff like run this script, run these arrays, and go. And so basically, by taking this really low-level command line tool and then writing your own automation layer on top of it, using all off-the-shelf tools, I mean, RightScale API, you can do whatever you want. Very cool. And the dry run also works from in here too. So, for example, if I wanted to do something like, oops, dry run. Oh, of course. All right, let's not do that demo. Anyways, it doesn't, the actual, I can't get this point across enough. The actual rake files don't matter. What I'm trying to say is take this tool, write your own files, use it in your own scripts, do your own stuff, automate all the things. Because that's the best. Okay. So, yeah, and yeah, so we pretty much just all talked about this. So one more thing that we found out, is that when we're working with the chimp, sometimes we needed to do a lot more. Sometimes we needed to say, I want to be running 50 things at a time or 100 things at a time, and I need to do this group of things and wait until it's done and then move on to the other groups of things. We actually have something called chimpd that can handle that. It's part of the chimp gem. And basically what it does is allow you to submit your chimp requests to the chimpd so you can do some of that automation. If someone's interested in that, I guess we can talk about it afterwards. I don't think we're going to have time to get into it really today. So we are almost out of time. Okay. So these were just the kind of tips I was talking about, trying to give out to everybody here. Always assume that your instances will die, because they will. And don't do things like make changes on your instances and then never save them. Always reboot, test server templates. Use tags everywhere all the time. Use chimp to make ad hoc queries. There's even a reporting feature in chimp that you can say, hey, what are all the IP addresses of all my servers? What are all of the IP addresses of the servers that are running Cassandra version 1.2? You can do that kind of stuff when you start tagging all your servers and you have a program like chimp. The next thing is, don't just monitor host metrics like disk space and CPU. Monitor your actual system. You know, have your application developers put in health checks, you know, that make sure they can connect to the database, make sure they can do what they need to do, that they have access to the resources they need to have access to, and then, you know, write a custom plugin for it like we did. Maybe it even is just graphing 1 or 0 if it works or not. That's great. And finally, and this may be the most important thing, design everything to be runnable in the server array. And this actually has a lot more to do with how the application is designed than necessarily your server template and everything, but very, very important, because hopefully someday that little tiny service running on just one server will be running on 1,000 servers, and that's where the server array will come into it. So I think we have a few more minutes if we want to do some more questions.
Are your alerts actually being triggered off of the data that the collectD daemon pushes up?
Yeah, I have the circles under my eyes to prove it.
Is all the agent monitoring happening through the write link agent? Is that what actually runs? No?
No. Yeah, very, very good question. So the question was, does the monitoring run through the write link agent? For those people that don't know, the write link agent is an agent that runs on your instance and actually handles connecting it to RightScale so that you can execute commands on it via the API like I was doing with the chimp. What's actually happening is we're just running collectD. There's basically a script that just installs collectD on your instance, and it is configured to send the monitoring back over the collectD native protocol.
First of all, my question is, how cool is chimp? I've never seen it before. Rhetorical. But did I see that you're passing in scripts to run by name, not by ID?
Yes.
Is there ID options? Do
Yes.
you not care about ID? Do you prefer a name? What's the deal there?
Very, very good question. So, one of the things about working with the API that you may have noticed if you've worked with the API is that when you're writing scripts or recipes and you're committing, different revs of things, it's going to change the API URL to that script every time. So every time you commit, it's going to change that URL. So when you're doing large-scale automation, you can't be responsible for going in there and updating 100 URLs every time, right? So that's where the chimp comes in. It basically looks up the server template, right? So when you say chimp, I think I had a tag one, right? So chimp -- tag, let me see. Here we go, okay. So okay. So, oh wow, I totally just got lost. What were you doing? Thank you. Yes. Yes. Thanks, Phil. Basically what's happening is you're specifying a tag, right? The chimp makes an API call. It says, get me all the instances with this tag. Come back, then go to those instances, look up the server template. Okay, on the server template, what scripts are there? Okay, what names do they have? Okay, that's a script. And the reason you have to do that is because the name of the script is not going to change, even though the ID does change.
So it finds the right provision of the script for
Yes.
the script per the server template.
Per the server template, yes. And as to your other question, you can run scripts with the script command line option here. You can use a raw ID. It will auto-detect that it's a raw ID. If you want to do essentially in any script, you can also specify API URL to an any script. And it'll just detect if it starts with HTTP and work with it like that.
Yeah, one comment to Chris's thing. One thing we use within RightScale just recently is we use chimp to pull all of the IPs of all of our running instances and then execute scripts for our vulnerability scans. So we've leveraged chimp. The ops team did it. We actually leveraged that to be able to get the instances and do things, scripts and things that we need to. So from a standpoint of other people in your organization being able to use it, if you use RightScale, it's a great tool. So.
As long as there's no other questions, I've got a slightly off-topic one for you as an operations person for RightScale. So you've probably seen lots of outages. What is maybe two examples? One, typical infrastructure outage that you see fairly often that your automation takes care of, and then how about another outage you've seen that really caught you off guard, and what you've done about that since?
That's a really good question. Unfortunately, I'm not going to have a really good answer for you. We're still in the process of rolling out and designing self-healing systems, essentially. The most common types of outages that we see are things like an instance died. Instances will just die, and you won't be able to SSH into them or anything. They're just dead. If it's in an array, then you can kind of deal with that by launching another server, etc. But we don't have anything right now that will automatically detect that and replace it on the fly. But it is something that we are definitely working towards. The other most common type of failure is EBS failure. So instances dying and an EBS drive just dying. Those are the two big things that I see happening. Yeah. All right, thanks everyone. I'll hang around for a few minutes if you guys have questions.